In this video, we're going to talk about naming ionic compounds. So we're going to use the formula to figure out first if it's ionic or not, which was review from the first video in this chapter. And then we also want to talk about how to name those compounds once we understand that they're ionic. And then also using a formula, using a name, figure out what the formula is. So this table here shows you the endings of your elements. But notice all of these are ones that form negative ions. So we're always going to have our plus ion first in our formula, negative ion second. Just as a kind of side note, extra piece here, the positive ion is always called the cation, and the negative ion is always called the anion. So our formulas are always written cation first, anion second. The cation is named simply by using the name straight off of the periodic table for that element. The cation is always the metal, so you find the name of that metal on the periodic table and you plug it in for the name. The anion will always change the ending to "ide." So again, this table gives you a couple examples. So bromine becomes bromide, chlorine becomes chloride, iodine becomes iodide, and so on. Also, with writing your names, there's no kind of indication of how many ions there are. And the reason for that is because you can always figure out the formula from charges which are consistent. So let's look at a couple examples. So we are going to answer these questions specifically about magnesium ion and the nitrogen ion. So the first thing is, what is the name of the compound? So our cation metal is magnesium. So again, we just pulled that name straight from the periodic table. The anion, the negative ion, so it's a nitrogen ion, so we're going to change nitrogen to nitride. So that ending becomes IDE. What's the chemical formula? We did this previously. We're again trying to get to neutral. We can think about it by swapping our charges for subscripts. So we're going to have Mg3 and 2. How many ions are present in one formula unit? So here's a new term. Formula unit is one piece of ionic compound. So ionic compounds are repeating units. Formula unit is just a single piece. And when we write our ionic formulas, that is a formula unit. So within that formula, there are 3 magnesium ions and 2 nitrogen ions. So there are a total of 5 ions in one formula unit. D wants to know how many electrons are transferred per formula unit. So each magnesium is transferring 3 electrons. Each magnesium is transferring 2 electrons, right? It's got the +2 charge. So if each magnesium is transferring 2 electrons and there's 3 of them, that means there are 6 electrons that are being transferred. A few more examples of formulas and names. So the first one, LiCl. Li is lithium. So cation you pull straight from the periodic table. Cl, the atom is chlorine, so that changes to chloride. Pb is lead. O is oxygen, and it becomes oxide. One other extra piece here. Lead is a transition metal. Transition metals do not have consistent charges. So we have to indicate in the name what the charge is. So in A, for example, lithium's in group 1. It's always a +1 charge. So I don't need to put the charge or the number of ions in the name because it can be figured out. Lead, however, can have a couple different charges. You could have lead with a +2 charge. You could have lead with a +4 charge. So we need to indicate what it actually is. So if we think about the formula unit here, we know the oxygen ion has a -2 charge. If there's only one lead to balance that out, it must be +2. So to indicate that we have lead with a +2 charge, we're going to use a Roman numeral 2. So you use Roman numerals when you have a transition metal, and the Roman numeral is equal to the charge. One common mistake is one to forget the Roman numeral altogether. The other common mistake is to use the number of ions rather than the charge. Okay, so it's not lead 1 because there's one lead, it's lead 2 because that one lead has a +2 charge. Next we have aluminum. It's in group 3, so we know its charge. Nitrogen becomes nitride. Notice there are spaces between the elements, right? Spaces, capitalization doesn't matter. Really, neither one should be capitalized, but it's not a big issue if you do. Next problems are going from the name to the formula. So here's where we need to kind of backtrack again and think about our charge. So potassium is in group 1, so it's a +1 charge. Bromide is in group 7, so it's a -1 charge. So +1, -1, I need one of each, so it's KBr. Gallium nitride, gallium, which is Ga, is in group 3. It has a +3 charge. Nitride is in group 5, so it has a -3 charge. So +3, -3, we need one of each, so GaN. Next we have cobalt-3 sulfide. So cobalt is CO. Remember the Roman numeral is the charge, so we have a 3+. And your metals, your transition metals, are always going to be positive. So you don't have to worry about deciding if it's positive or negative because it will always be positive. So cobalt-3 is +3 charge. Sulfide is in group 6, so it's a -2. So here to get equal pluses and minuses, we're going to need 2 cobalts and 3 sulfides.